Okay, so looking at, can someone get the door for me, please? Thank you. Reading through this problem, it's not like it's an issue anybody in here has ever heard of before, right? Never? Never? Yeah? Deflategate? Carissa. Okay, so this says, how could we use a retrospective study to determine if the home teams have an unfair advantage? Okay, so when we're working through that problem, tell me a couple of key words in that question. What are some key words in that question or in that problem? In this. Retrospective. What does retrospective mean? You're looking in the past. You're looking at data that you already have to answer a question. Okay. Anybody have any ideas how I could do that? Yeah. Okay. Look at how they performed in their past home games versus their past away games. We do need a little bit more because when we design a study, you've got to be a little bit more specific. Okay? Mm-hmm. So you're saying, and let me just make sure that I'm getting this right. You're saying look at free throws for both home and away games, for the team in question, and pick one other team or all of the teams? With the team in question. Okay. The thing that you want to make sure that you're clear about here is how can I compare home free throws to away free throws? Tell me some things that might get in the way of kind of being able to understand that. What about home court advantage? Mm-hmm. The crowd cheering for them. That's what, when they talk about home court advantage, usually it doesn't mean I know all the sweet spots in my court. It means you have the cheering fans are for you. They're not against you. They want to do to help you instead of hurt you. The other team they want to hurt. Now, are there other places where you get home court advantage? Yeah, it used to be that some of the older basketball courts spots where it wasn't supported as well from underneath. So if you bounce the ball on that spot, it just kind of doesn't react the way it's supposed to. So you had multiple things kind of playing to you. As a little bit better with our building, that happens less often, and the more popular things are becoming, now it's like home court advantage can be huge. You think about that for football or anything else, because that crowd is for you. You're pumped versus you're going, oh my goodness, that's not cool. Okay. So let me kind of give you what I have as an example here for an answer. So first thing, you don't need to state what a retrospective study is, just making sure that you understand. So we're going to look at past games. So I believe both of my examples involved looking at past games. So you want to make sure that you state that in order for it to be a retrospective study. Look at the rebounds, because that's what we're talking about. We're not talking about the free throws themselves. We're talking about the rebounds. How many rebounds were you able to get? So then what we're going to do, and this is very important, you need to talk about your response variable. What is it that I'm looking at? I'm going to either look at the number or the percentage of rebounds that we made in each of those. So you're going to compare the difference between your rebound average or rebound totals, however you want to talk about that. But notice in this, I can clearly state I can clearly identify what my variable of interest here is. I can talk about what kind of things am I comparing Comparing rebounds, I can tell who I'm talking about, and I can talk about the fact that this is past games. That way it identifies all the things that we need. So for number 2, when it says describe how to use a prospective study, again, you want to make sure that you're identifying those things. When is this happening that I'm looking at it? What is my response variable? What am I comparing? And am I doing anything special? Like I didn't do any, you're right, I didn't do any blocking, nothing special. I just looked at past and present. Okay, so what do you think for number 2? Any ideas? That have completely shot all of your confidence? Of 2 people, 3 people sometimes, who talk. Give me something, come on. Everyone's like, don't make eye contact. Can you just read? I see you. No, you don't have it. That one. Dang it. Who's got something written down? Everyone's going, cover your answers. Do you read me what you had for number 2? Okay, so that's a perfect start. So no matter what, you're trying to describe it as a prospective. So that means you are going to watch the home games. You are going to record data. You just want to make sure you're clear on what the data is. Data about rebounds from free throws. Okay. And then you're going to record the same information from away games. Okay. And what am I going to do? What am I interested in learning about? Comparing your percentages of rebounds made. Good. I would be a little concerned. I'm just kind of throwing in my own concerns as we go through here. I would be concerned because you play a game one week, you play a game another week. Not just location has changed. What else has changed? Time. Huh? Practice. If we've got I don't know basketball teams. If I have a team playing this weekend and they play the next weekend, are they going to be playing the same team? No. Do you think that has anything to do with it? Yeah. All of a sudden, one day you're playing like a really, really good team and you might not make very good rebounds. It might have nothing to do with home average. Or home average? Home field advantage. Home court advantage. It doesn't have anything to do with that. It has to do with the fact that once you played a good team, the other time you played a bad team, and it was just like taking candy from a baby. Versus the other one, you were the baby with your candy taken away. Okay? So again, we're talking about for prospective, you're going to identify your issue and then collect your data. Yes? Well, the problem with this, and I definitely recognize the bounce height issue because that's about predictability and everything like that. But, and I guess here they do say shooting free throws. They're not very clear there as to what the problem is. But, oh, here it is. Describe how to use a retrospective study to determine if they had an unfair rebounding average. So that's the thing that we have to understand that we're paying attention to. They talk about a lot of different things. I'm totally with you. I know that inflation on the ball is going to make a huge difference in how it responds to when you're handling it. But this question is going specifically when they're talking about shooting free throws and free throw rebounding averages. Okay, it kind of bounces back and forth. That's not a very clear question, is it? So I would definitely go with either recording their free throws or recording their rebound average, simply because it's not very clear. So for this one, again, you select your teams, you collect data as you go through to see if there is a difference between home field or home court. I'm in football mode. Home field advantage is where my brain's at. So home court advantage versus away. Okay. All right. Now experiments. You've got to be very, very careful with experiments. You have all those little pieces that you have to identify. What's the first thing that you need to identify for an experiment? Not really. Those are things. Those are elements of an experiment. You have to control, replicate, randomize, block. Those are things that you want to incorporate. But for example, what is my subject? What am I studying? Basketballs, the rebounds. I'm kind of just looking at, believe it or not, the teams here. Does that make sense? I'm studying the teams and the games that those teams are playing. So there's a lot of different ways that you can kind of state that. But you want to make sure that you're talking about the right thing. Whether you're talking about looking at the teams or the games or each individual shot, you've got to have all of that in there. Okay? So my first idea is making sure I know who my subjects are. Then I need to have in order for it to be an experiment, what do I need? I need to manipulate something. Absolutely beautiful. I need to have some kind of a treatment. What would my treatment be? Type of basketball could be something, but I don't think that's really what we're studying. What are we interested in? Whether or not something affects something else. Home court. Home court is one of the aspects that we're looking at, but that's not really what we're studying. The deflation of the ball. So the treatments, because that's what I'm looking. I'm not really looking to see if there's a home court advantage. I'm looking to see if when they are at their home court and they're using their own balls, does that provide an advantage? So that means my treatments are going to be what I do to the ball. So maybe a regularly or standard inflated basketball, they do have strict regulations on that. And then something that is underinflated. So when I talk about those things, standard versus underinflated, what are those? My treatment is the air pressure. Standard versus underinflated would be those would be my levels. And you can get specific here. I mean, there was a certain gentleman a couple years ago with a certain air pressure question in a certain brand of sports. Totally honest, right? America's quarterback. No. America's liar. Cheater. But they've shown that slightly under pressurizing whatever the ball is, it affects basketball by the way it bounces, by the way it rebounds, all that kind of stuff, but it also affects how your grip on that ball can be. If you think about it, if it squishes a little bit more, you have a firmer grip on it. Like if you're throwing a ball in a spiral pattern towards somebody across a larger open space coated in grass. No one knows anything about what I'm talking about, right? No idea. So my response variable. My response variable, what am I going to be measuring? Number of, pick one. I don't care. Free throws. Number of free throws. Well, I wouldn't go with number of free throws because free throws, yeah, but still, even if you're talking about number of free throws, I'm looking at, percentage. The reason why is you get easy for me to say, free throws typically when you're fouled, right? If you don't have many fouls in a game, you're not going to have many free throws. I said it right that time. So that's why you're right, Ryan. Percentage is more what we're looking for. So if you're either going to say percentage of completed free throws or percentage of rebounds that team made, that's more what you're in line for with that. Okay? So that's what I'm measuring. And specifically, what do I want to know? Do I just want to know their free throw percentage or their rebound percentage? Good. You want to compare those two different treatments. Okay? You want to compare how they did with the underinflated versus with the regular inflated balls. Now, my design here has lots and lots of words. basically you want to kind of set the stage. Because this is something that's kind of tied to ability and knowing ahead of time, we can say, okay, the home team is going to practice with the underinflated balls. Then they go and they do their games. They might not know that they're practicing with underinflated balls. Maybe they do know. I don't know. I don't know who was in on the whole Deflategate debacle. Was it just the quarterback? Was it everybody? I don't know. So we've got teams practicing with it. So this is what they're used to. Then we go to game time. We randomly pick what kind of balls they're going to use. Underinflated or regular, standard. Regulation. We record either their free throw percentage, their rebound percentage, whatever it is you've chosen to focus on because that question was not well defined. Yes? I like that. He's talking about how we understand there are other aspects of a home court advantage that kind of can affect you. So how would we do that? Mm-hmm. Okay, so what we're doing here is we're taking it completely out of the mindset of a game and saying let's just practice with the throws and let's just record how these different teams do. Mix them up between them. And that's fine. Okay, about addressing the issue at home. Okay, so comparing the results, yeah. And whether you want to talk about randomly assigning to games, like some of your home games you'll have the regular, some of them you'll have underinflated, it'll be randomized. Maybe it will be that the first 10 games and the second 10 games, however you want to work that. Trick here. What do I need to have in a good experiment? Manipulation, which is your control. What do I have control over? The air pressure. What else do I need? Randomization. So I do need to include some kind of randomization. Either that's going to be in randomly selecting which ball you're going to be playing with, or randomly selecting if you're talking about teams, you're going to be randomly selecting the order, like you're going to mix up the balls as they go through, and you're just keeping track. They've got numbers on them. What happens when they have different numbered balls? You have to have randomization in there someplace. What's next? Replication. What does it mean by replication? Doing it over and over again. Having a sample size. Getting a lot of people in there. So you're not going to just look at one game or one player. You're going to look at multiple events. Blocking. Maybe if we want to block to improve, because we were mentioning about, we don't know if this home court advantage is just about the balls, if it's about the audience as well, the spectators. Maybe I randomly assign all of your home games to standard regulation or underinflated balls. And then I block all of your away games. And I randomize between standard and underinflated balls. And I'm going to look at just the home games and just the away games. Because I have a feeling the home games themselves might have an impact on how well we perform. Does that kind of address what some folks were saying with the home games and the away? A little bit? Okay. Now, you could say that this is double blind. Now we're making it a little bit better as we go through. The big thing about double blind, and this is so important that you understand this, ladies and gentlemen, double blind means the people directly involved in participating in the experiment. Okay, anybody that's doing like face-to-face interaction with this experiment doesn't know that it's going on. So that means the players don't know that they're being tested on underinflated and overinflated balls. And it depends upon the degree of inflation. Like you're thinking about like when you're literal and you're playing with a basketball and you pull something out of your garage and it's kind of, you notice really big. But what they're talking about here is just 1 pound less. And so the difference between 1 pound less in a ball, you won't notice by touching it necessarily. It's more like if I drop it from a height of 6 feet, the bounce might return 5.5 feet instead of 5 3/4 feet. So it won't be that glaringly obvious. You see, I know bikes. I don't know basketballs. Does anybody know what the PSI is for basketball? I think it's like 30. I'm not going to look. You think it's 16? Yeah. Yeah, because, that's what I'm like. It's just going to be, the balls are going to be the same size. It's just going to be a slight difference. It's not going to be enough that when you're like, unless you really push on it, because you know how you can really push on a ball to check to see if it's inflated properly or not, you might get a little bit more wiggle room, but it's more going to be those subtle differences that it's talking about. But for double blind, yeah.
So I'm a little confused on what exactly are we testing? Are we testing to see if the coach did it?
No. I know that's the thing is we're not testing to see if the coach did it, because yes, people would have, when you're thinking about the other instance, they're testing to see if he did it, and this was a huge problem that year. What we're testing to see is, okay, if they do this, does it actually provide them with an advantage? Okay, everybody understand that point? We're not looking to see did they cheat or didn't they cheat. We're looking, did that action provide them with an unfair advantage? Maybe it does, maybe it doesn't. Maybe it just screws everybody over. Everybody does worse. Okay? But again, double blind, those who are directly involved with executing the experiment don't know what's going on, but also those taking the final measurements. Whoever is observing and recording what happened at each event, they don't know either. Because if you're watching basketball games, there's usually people on the sidelines who keep track of exactly where shots were thrown, who rebounded from where, whether it was good or not. I have no idea how they do all of this, but they have a little chart and they keep it up and it's like crazy. That person can't know what's going on either. And nature and scope, they throw this around a lot, and it's frustrating. I don't like to talk about it too much because I literally, one year, spent hours looking for a definition of nature and scope online. There wasn't one. Nature and scope just basically talks about what are the goals for your experiment, what are you trying to accomplish, what are some possible issues that you might face along the way. So we've already talked about, first off, they're not very clear as to what the goal is. Am I looking at free throws made or not? Am I looking at rebounds received or not? And then I need to look at what things might affect it. So the actually idea that they're in their home court with their own audience, their own spectators, might affect it as well. Okay, so we're not going to look at that too much. All right, so what we're talking about today is just really kind of hitting home on these ideas a little bit more. So keep those notes out because we're going to keep working through the problems in your paper. But what we do for every single experiment, do you guys need to stand up and kind of wiggle a little bit? I've seen a lot of people who are really, that's struggling. When you're using your pencil case to hold your head up, that struggles. Just whatever. Okay, so when we do this, we always want to first identify things that might affect our outcome that we know about. And we try to control for those. If I know audience participation might affect how I perform on America's Got Talent, maybe I try to make sure that the audience always replies the same way. It's called a laugh track, or one of those like clapping thingamajiggers. They set the level. And the control can come in many ways. So we can do control groups where we have one group that's not receiving a treatment. Sometimes that doesn't work. I'm not going to have a control group of basketball players not receiving the ball. You get it? Get it? Wink, wink, nudge, nudge. You're in my experiment, so I need a control group. I need to see what happens when you don't have any air in the ball. Here you go. Disc. Boom. Blinding is a way of control because how many of you are in AP psychology? AP Psych? Are you guys going a little bit of deja vu between the two classes? It's just like, oh my Lord, it's the same thing. Okay, so blinding can help because just sometimes there's even a gigantic physics concept. Anybody watch Big Bang Theory when it was on before it went out? The idea that something is observed affects what happens to that object at all. Does anybody know what that's called? I don't remember. Quantum physics. Big Bang Theory. Yeah. Kind of sometimes that the fact that you are observing something is going to affect how it happens. And that happens all over the place. The fact that sometimes teachers have administrators come in because we have to be observed, it's just part of our contract. The fact that an administrator is in this room, there isn't one, is going to completely affect how the students behave. It's hilarious. You go from having the craziest kids in the whole wide world to all of a sudden they're angels. Miss. It really is quite funny. And then placebos. That's the idea of sugar pills. My AP Psych folks are going here. Yeah. So placebo is the fact that just you believing that you're doing some kind of a treatment can play a huge role in how your body responds or how you respond in general. Doesn't matter. If you know a treatment, no matter what that treatment is, that does play an effect, which is why a lot of medicinal commercials you'll see versus the placebo. They responded, the placebo ended with like they'll do like the smoking patches. Say the placebo helped 25% quit within 3 months, whereas our patch helped 65% quit within 3 months. So say just the fact that you're thinking about it can play a role. We block what we can't control. I cannot control your gender. So if I think gender is going to have an influence on how fast you run, I'm going to block by gender. They're called the Olympics. Earthen is blocked by gender in the Olympics. Okay? Any type of sport is typically blocked by gender because there's a difference between guys and girls. I hate to admit it. We're built differently. We have different chemicals coursing through us at different levels. There's differences. So if I can't control it, but I know about it, I block it. We randomize so that all those little things that I might not be aware of, all those little things get hopefully equally spread out amongst all the treatments. Hopefully. It's not guaranteed. And then we replicate to make sure that my final results are not just, surprise, it happens every once in a while. Yay! If I go out and play the lottery today, it just might happen that I win. But I might be playing for 20 years and never win. Which is probably going to be more likely. At least not the big bucks. So we replicate to make sure that whatever outcome that I have, that's that kind of predictability. To make sure that it actually is valid. So I love this. Now that you're fully recovered, Mr. Dawkins, we can tell you the truth. The 12-hour operation, the intravenous meals, the 3 weeks of bed rest, were all part of an elaborate placebo effect. And she's like peeling the sticker of stitches off of his chest. I think that would be like, what? 3 weeks of intravenous meals? Oh, heck no. Oh, I didn't realize they were going to do that. Okay. So, there is one of the biggest difficulties that people have with this unit is this idea of confounding. A confounding variable is basically something that kind of might affect our response, but we're not looking at recording it. We're not looking at measuring that. So our goal is always figure out how this one factor, how did those basketballs and inflation rates, how did that affect their abilities to play the game? That's what I'm trying to measure. All of those other little things that come into place that I know about are going to be confounding factors. The fact that you have your own audience, confounding factor. The fact that the other day at practice, you guys were just on it. You were killing it. Versus the other team who the previous day at practice, 5 team members got hurt. Okay? Those are confounding variables. There was I don't even remember who it was. There was a football star who Ben Roethlisberger, right? He's out for the season. Does that mean that his Is that going to affect the team's home game records? Got your major player there. How does that affect it? So you have these confounding variables that might play a role. Heck, the weather plays a role. Maybe not so much in basketball, but in football it definitely does. In golf it definitely does. And anything where you're outside, it definitely does. That's a confounding factor. We don't want to measure what that effect is, but it's still there. Okay? Now there are things called lurking variables. Here's the difference between a confounding variable and a lurking variable. You guys ready for this? A confounding variable you know about. Period. Confounding variables are the ones that you know that are out there. I know that I want to figure out what my average time coming from home to school is. So I'm going to record that multiple days. There's a really big confounding variable for me this morning with two accidents on 15. I had to turn around and go another way. I had doubled my time. That's a confounding variable. I know other cars are going to affect my time travel to school. Avoid it. A lurking variable might be something I'm not quite aware of, but still plays a part. For example, I might not realize that there is a cop sitting in the corner observing people, and some folks are seeing him, I didn't see him, and therefore going much slower than usually would. That's a lurking variable. That cop is a lurker. He's a creeper. He's just sitting out there. If I know you guys are watching me in the front of the classroom, I will behave one way. But sometimes there's administrators standing at the door and I just didn't see him and I'm acting a fool. That's a lurking variable. Creepers. Okay? So, when we're talking about experiments, there's a whole lot that can go wrong. That doesn't mean you should, find that. There's so many different things that can totally screw this up. I might as well not even get started. Please don't do that. You'd look really ridiculous, as I'm sure I did right there. Don't give up just because there's a lot of places where it can go wrong. That's why we do it over and over and over again. We randomize because of all of those little things. I'm going to randomly pick for my fantasy football team. Randomly pick from all bunch of different teams to hopefully cover any issues. Like maybe one year, one of the football teams' home stadiums gets hit by a hurricane. I can't control for that. I didn't know that was coming. So I didn't pick all of my fantasy football players from that one team. Kind of spread out the love. Okay? So we randomize to also kind of even out those issues, and we're always paying attention. And that's why a lot of times when you're doing experiments are rarely run by one individual. Because you get focused. You get focused on your work. You get focused with what is in your world. You don't see all these little things on the outside. So they have a lot of different teams coming at them. So they don't even call them statisticians very much anymore. They call them data analysts. Because they work in teams. Each person focusing on something slightly different, but aware to the whole process. So that you're paying attention to what can go on, so that you can talk about what goes wrong. And when something goes wrong, you state it. I had to do an experiment last year on popcorn. I apparently do not know how to pop popcorn. I thought you were supposed to wait until there were like 5 seconds between kernels popping to take it out of the microwave. There was quite a bit of burnt popcorn. And it was unfortunate that I was popping it, and when I took it out of the microwave, the fire alarm in the school went off. I thought that was me. It wasn't. I clarified. It was planned drill. But I was like, what? Oh my God. I stated that in my paper, and I was like, you dork of a professor. I hate popcorn. Stop making me do this. Or get someone who knows what they're doing. That'll work better. And the whole room smelling burnt popcorn. So that's why we always kind of record what we think that's important and everything else also. Just in case. That's why when you go to the doctor, You don't just tell them what you think is important. You give them a whole field of symptoms, because you might not realize that the fact that your hip hurts might have a play in why you're sick all over. Okay, you don't know. And here's the big thing. Big piece of advice to anybody that goes out and produces experiments. Do not blow all your money in the first shot. Typically, experiments work cheap, and then they move to expensive, which is why you start with lab rats before you go to pigs. And I'm not saying animal testing is a good thing, but this is why they work that way. They'll do with lab rats, and they'll go with slightly larger animals and slightly larger animals. And only once they've gotten through everything will they then move to humans. Because if something goes wrong on a human, that's money right there. That's a goodbye to all of your money ever. A pig is not going to sue you. I say pigs because they are extremely similar to humans in physical makeup and reactions to things. I know, you're all just so interested right now that you can barely contain your excitement. All right, so don't forget, you got to know your principles of experimental design. What are they? Control, randomize, replicate, block. Actually know what those words mean. So you're going to control sources of variability that you know about. Okay, however that means, whatever you need to do, blinding, placebo, just a regular old control group. Identify things that you know about. Reduce them if you need to. So what we do is we control what we can. We randomize for the stuff I can't control. And then I block what I can't control, I can't randomize, but it's going to affect anyway. And, yep, replicate, replicate, replicate. All right, so practice. This is in your notes. We haven't talked much about completely randomized design, matched paired design. That was in the video. We're going to talk about that here. Yes, ma'am. Quickly, please. And for this guy, you can use words, you can use pictures. All right, so when we are talking about a completely randomized design, all we're doing is random. Ready for this? I got some subjects. I have no idea who they are, what they are, whatever. I've got subjects. Completely randomized means I'm going to use random assignment. And I'm lazy. I'm just writing RA. And I'm going to take half of them to take their pulse rate while sitting. And I'm going to take the other half, do their pulse rate. Guess what this one's going to be? Standing. And then all I'm going to do is I'm going to compare. That's not how you spell compare. There's no I in that, I don't think. Shut up, don't laugh at me. I'm going to compare their heart rates. I saw a question, yes.
So,
You can.
would we have to specify because I feel like the things in gender.
If you know those things, this is completely randomized. Doesn't matter. All we want is whoever my subjects are. If you want, maybe you're going to put 50 subjects here, and then on each of these pieces, you put 25 and 25. So if you want to do it that way, that's great. Completely randomized design means whoever you're doing, you are randomly assigning them to the two different groups. Yes.
Why wouldn't you want to compare, like, how each individual person is?
Ding, ding, ding. You do. That's a good thing. But this is just saying to do a completely randomized design. That means the only design technique that I used here was random.
So it's not the best.
No, it's not the best one. It's just one design we can use.
Each person randomly do sitting versus standing.
No. That's what we're going to be doing next. That is not a completely randomized design because it's not just randomly assigning my 2 treatments. Subject to 1 treatment randomly assigned. What you're thinking dun, 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 is what's called the matched pair design. Okay? You guys ready for this? Because you were making a perfect argument. What were you talking about? So he's talking about saying have each person randomly start with either sitting or standing, and then do the other one, and they're looking at their particular heart rates for both of those. Why do you think that might be important to do? Yeah, different people have different heart rates. I have a very, very strange heart rate. I have issues, something called POTS, so that when I'm sitting, my heart rate will be very, very low. But if I change positions at all, forget exercise or anything like that, my pulse rate will either skyrocket or drop. So if you ever see me getting out of the chair and I'm dizzy, don't worry about it. I know what's going on. I'm okay. That's what? Nope, different. Yeah, it's a cardiovascular issue. But yeah, sometimes iron does that also. But because of that, you've got each individual person. Maybe you have somebody who's like a marathon runner, and they're beast mode. Sitting or standing is nothing for their heart, so it's very, very similar. What if you got somebody who does nothing but sit on the couch watching TV all day? I'm not talking about myself or anything, but maybe that plays a role. And it's exactly what we were talking about over there, where we're saying, look at each person back to forward. So what I would do is I would take my subjects. I like drawing this in a picture. I think it's very, very nice. Absolutely. But I like the pictures a lot better. And I'm going to randomly assign my subjects to one of 2 groups. One group will do sitting heart rate. The other group will do standing heart rate. Then this group moves to standing. And this group moves to sitting. Understand what I'm talking about there? What we're going to do is with this, I can still compare. I don't know how to spell compare. This is so sad and embarrassing. So I'm going to compare, and I'm going to set an order. No matter what, I'm going to do the standing minus the sitting. Because I think your standing heart rate is going to be a little bit higher, and I want positive numbers. So I'm going to compare their standing minus sitting heart rates. So that way I've got an even distribution here between folks that stood first, and folks that sat first. And I've got them all grouped by individual so that I take that out of it. So the completely randomized design, the main object there, and you can see here both a picture at representation and a written one, from a group of assignments, randomly assign, half of them to sitting, half of them to standing, calculate, and compare pulse rates. Words or pictures equal good. For the matched pair design, everybody does both, but you switch up and half does sitting and then standing, half does standing and then sitting. And then you compare the pulse rates. For something like this, You can either talk about comparing separately, which is a true matched pairs design like I've got here. I'm going to compare standing to sitting. I'm going to compare sitting to standing. And if we're doing it that way, you understand that sometimes if you stand first and then sit down, your pulse rates might be overall a little bit higher. You can actually get an idea as to what's happening within those groups. Okay? So, we're just going to continue building some of these designs here. How would we analyze the effects of nitrogen as inflators and ties? Yes? Uh-huh. Because what's interesting is if you're sitting first, you're fully relaxed, your resting heart rate is typically much lower, versus when you're standing, you're going to start at a higher place and then go low. So one goes low and then high, the other goes high and then low, and it doesn't always affect everybody equally the same way. It's one of those things that unless you've actually done that experiment before, I think I did it in middle school, it's really interesting to see how the difference is. But for me, if I were to stand first, right now I can feel my heart working a little bit harder, but my blood pressure is crashing right now. Whereas if I sat first, I would be stable. And then it would, I recover better going from standing to sitting than I do sitting to standing. So it depends on the person. Okay? All right. Are you guys familiar with the fact that some cars use nitrogen in their tires? Why do we use nitrogen in some tires? Do you know? Okay. Used in run flats. Does anybody know why we use nitrogen in tires? I'm just going, no. Of course not. They use nitrogen in tires. Yeah, go for it. It does have that. It has less of a reaction to changes in temperature. So there's that. But also nitrogen is supposed to escape less, have more. It's going to be, since slightly larger molecules are not going to escape from the tires quite as readily as air does. You inflate a tire, I don't care how nice your tire is, it's slowly going to deflate. Yeah? Yeah. No, for example, my car came with nitrogen, and the little, even if you look at the covers on the tires, they have a little N on the covers for the air pressure. It's best to then refill it with nitrogen, go to an actual auto shop and have them refill it with nitrogen. It does cost money, but you can go, I was like, yay, it has nitrogen for the first and only time I ever have air in it. And then after that, I just refilled it with standard air. But you just have to know that standard air reacts stronger to changes in temperatures. Like now, every time it gets cold, my tire pressure low light comes on. Every time the temperature dips. Versus with nitrogen, you don't have that happening as frequently. So you would have to go into a store, and it just depends upon, some people are real snooty about their cars and the airs in their tires, and they are, I don't know, I'm not one of those people. I'm like, dude, what's cheap? I've switched to using regular unleaded because premium was too expensive. So I don't care, whatever. But yeah, it does play a role here. So what we want to do is we want to design an experiment that is a completely randomized design, one that uses blocking, one that uses matched pairs design. So if I'm talking about completely randomized design, what am I going to be doing? Mm-hmm.
So we have tires, and then we still have nitrogen and also air,
Mm-hmm.
and we just compare.
Yeah. All you're going to do is you're going to say, okay, I got a bunch of tires. Completely random. Means the only thing I'm looking at are the tire pressures. The air in the tires. I'm going to put half of them to nitrogen, randomly. I'm going to put the other half to standard air, randomly. And I'm not doing blocking. I'm not doing anything. So at the very end, all I do is what? Compare. Maybe it's air pressure. Maybe it's how long the tire is able to maintain a certain level of air pressure. Maybe all sorts of different maybes. But basically, for completely randomized design, here are the words for it. I kind of like pictures. So what I would say for completely randomized design, I would say tires, and I would say a broad range, because there's Michelin, there's Continental, there's Costco brand, which is where I get my tires. All sorts of different things. That might play all-weather tires, summer tires, winter tires. I don't know. Not a car person. So you've got a broad range of tires, and I'm just going to, what do I need to put here? RA. If you don't say it, it didn't happen. RA. So you're going to randomly assign it to tires with the nitrogen treatment and tires to the standard air treatment. And then we're going to compare something. For crying out loud. My goodness. Now I'm just doing it on purpose, I think. My brain is doing it on purpose. Compare air pressure. However you want to do that. Or compare effects then. Comparing the effects. Now, when do I use blocking? When you what? When they're going to group things by their characteristics. A little bit more specifically, when you know that there are characteristics that might affect how they perform. So if we're talking about tires, I don't know, tell me something that you think might affect a tire's air pressure, how it performs, regardless of nitrogen or one more time, size, brand, what else? Type, because you're looking at all weather tires versus just the winter tires or whatever. So I don't care. I'm going to say, because it's something that I know right up in front, I'm going to block by brand. So I'm going to take my broad range of tires, and I'm going to block, let's say, Michelin. No idea if I spell it. It's 1 L or 2 in Michelin. Nobody knows. Nobody cares. Michelin, Goodyear. And let's do Costco for the teachers in the group. Or the college students or whatever. So I'm going to block by brand. And then within each block, what am I going to do? I'm going to randomly assign. I'm going to randomly assign it to nitrogen or standard air. See, I'm being lazy. Don't feel like writing it out. Now, here's the thing with blocking. Once you block, you can never go back. So that means I am only going to compare results or compare effects. Look, I spelled it right. Within each block. Because the nitrogen versus standard air might react completely differently between those different brands of tires. So maybe the nitrogen shows a really big difference in Michelin and Goodyear, but it really didn't show much of a difference at all in the Costco. So this allows me to kind of eliminate the effect that the brand might have and look more specifically at what the effect that the air type has. Now, when you're doing matched pairs, that's when we're saying, I know that there is something that exists to make every single thing kind of unique. I know it's not just Michelin and Goodyear and Costco. Maybe it's Michelin on a Civic versus Michelin on a Ford F-150. Those might be different. Matched pairs is when you can get either the same idea to do both, or identical ones where you say one to one, one to the other. It's kind of like the idea of twin studies. Used to be something that they do until they realized and determined that was completely and totally, horribly unethical. So they would literally split up twins between families to see what would happen. Identical twins. How did that affect how you were, nature versus nurture? Really big studies they did. Unfortunately, they did a lot of those studies using chemicals in World War II. Because you had two very, very similar bodies that should react the same way, whatever stimulus they get. So, matched pair, let me go back to the blocking. So the words blocking, you would just say block by manufacturer if you wanted to go even further, by model, by size, whatever you wanted. But then within each standard error, and you only compare within each. Whoops, not what I wanted to do. So if I'm looking at the matched pair design, where's my count? There it is. What I'm going to have this guy do is I'm going to have a broad range of tires. And let's say for my broad range of tires, I have 2 of each. So I have 2 Michelins that I'm going to put on a Ford F-150 of a standard size. So I'm going to test it on 2 cars. I have 2 Goodyears that I'm going to test on 2 Ford F-150s. 2 sets. Does that make sense? So for when I have a broad range of tires, and honestly, for matched pairs design, sometimes this is one of those where it's easier to actually say what you're going to do rather than to draw it. But for a broad range of tires, what I am going to do is randomly assign one from each into the nitrogen and the standard air group. And then I'm going to compare the effects only within the pairs. I'm only going to look to see how it affects, go ahead, and compare it within those pairs. So I think matched pair is almost always harder to kind of draw a picture than it is to just write. So I like writing pictures for randomized design and blocking because I think that's quick and easy to say. But for matched pairs, I actually think it's better to just write it out. You got 2 tires of each. One will randomly get nitrogen, one will randomly get standard air, and I'm going to only compare within each type. And again, it can be difficult to draw a picture with matched pair. Don't feel like you have to draw pictures for this. You draw a picture if you think drawing a picture is easier. I'm not making you do that. I just find I'm a visual person. Pictures make me happy. Y'all want a happy teacher, right? Right, Club? He's like, yes. All right. So those are just in there. Let's try some problems. These are no longer in your notes. Oh, by the way, before I go too much further, just to make sure y'all are aware, we have one more investigative task for which we're going to... What is this? Please! I mean, for crying out loud, you get literally step-by-step instructions as to what you need to do here. I don't want to hear it. Again, I want this typed, and it will be submitted online either as a .doc, .docs, or .pdf. I don't care, whichever one is better. If you have a diagram, like if you want to draw a picture rather than use words, just make sure that it's in there. I don't care if you take a picture of it and then put it into your file, whatever works for you. But please, 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 your own work typed on Canvas 4 excavators and cranes. Make sure that your file's not blank when you submit it. That'll be due the test day. So there'll be quite a few things due on the test day. So I'd start working on them now. Or maybe I'll make this, I'll take a look and see when I want to make that due. All right, until then, you guys do this. No, these are purely for you. They don't word good. Only for you. I'm going to be nice. Yay! Wait till I say it. I'm going to have your excavator and cranes task due on September 26th. So it'll be next week, Thursday. So that if you need to focus on the test and other things, because I know that I've got a few last minute people in here, that it's not 50 million things to do last minute. Understand? Yes. Yes, absolutely. All right. Migraines. Read it. Talk it over with your neighbors. For this problem, what are my factors? Overall factors. What things do I think affect your migraine? Yeah. What you drink and what you take. Now, I'm being very general with that for a reason. The factors are the overarching things that you are going to manipulate. I'm going to manipulate what you drink. I'm going to manipulate what you take. Yes? Right, because those are the factors. What did you give me? Below factors, there are levels. So within the what you drink factor, your levels are ice water or no water? Normal water. I was like, not. Yeah, it's like I would kind of like, not many people can like dry take pills. That's not fun. She's like, some people are like, I can't. I'm awesome, hardcore. So what we have here is we have participants will either drink ice water. Half of them will just drink like room temperature normal water. So that is my what you drink factor. What is my what you take factors levels? Placebo or the pain medicine? Because what we're trying to figure out, is it just the pain medicine? Is that what's really doing it? Or does the water that you drink that with, does it actually affect it? Okay? So how many treatments then are there? 4. 2 times 2. You can do ice water with pill, ice water with placebo. Regular water with pill, regular water with placebo. 4 treatments. What is my response variable? What am I looking at? And you can state that in a lot of different ways. You can say, okay, give them everybody an hour and say after an hour, how much pain relief did they get? Or maybe you say on a scale of 1 to 10 when it starts, and a scale of 1 to 10, certain time later. No matter what, you're looking at their pain relief. Something about that. Is there any blinding in this study? Yes. What is it? The placebo. You could also say there's another level of blinding. The placebo, obviously, the sugar pill or whatever. But you can also say, like, the people don't realize that I am studying the water also. So maybe they just, here's something to take your medicine with. That can be, yes, they're going to recognize the difference in temperature. But you're not going to have one person doing both methods. So they can just come up to the window, here's your medicine, here's your water to wash it down with. Do you understand what I'm talking about there? They know what's going on. They don't realize that that's part of it. So hopefully that won't affect them in the same way. So there's no blocking. Tell me something that you might block on when dealing with migraines. Age. So younger people versus old fogies. What else might I block on for migraines? What might affect your migraine levels? Gender. Gender could be a big player. Is there anything else that you think might be able to affect migraines? Maybe general health. Maybe whether they get chronic migraines or not. All of these different things can play a role. So with these guys, really it's all about practicing problems. So there's the answers. So I've got a lot of other things in here that you can practice. Maybe we'll have some time to go over these next class. But no matter what, you have your 3 things for Khan Academy. Those are going to be due tomorrow night. They're due tomorrow night, the night before the quiz. Okay? It says it's due. I probably entered that in before I realized that we were on odd days, not even days. So I will fix that. Okay. Oh, God forbid you can't wait to the extremely last minute. Cry me a river. Your excavators and cranes will be due, like I said, next week. So what day is today? Today's Wednesday. So I see you Friday. We'll be taking the quiz over Chapter 12. Tuesday, you'll be taking the test, and so they'll be due, next week, Thursday. Okay? You all good on that? We are getting closer to the test. I cannot express how helpful those alternate problems I have listed on your outline are to how well you do on the test, how well you do on the quizzes. And I have all of those answers posted on Canvas as well. Okay? All right. And you guys should have received an email yesterday from me about AP Classroom. Please make sure you all get enrolled. We will be trying to use that possibly next class.